When wiring a split-system air conditioner, it's crucial to adhere to both the National Electrical Code, or NEC, and the manufacturer's instructions to ensure safe and compliant installation. Let's delve into the specifics based on the information provided. The NEC provides guidelines for sizing conductors and overcurrent protection for air conditioning equipment. NEC Section 440.22 states that conductors for air conditioners shall be sized in accordance with NEC Article 440. NEC Section 440.32b specifies that conductors for circuits supplying motors shall have an ampacity not less than 125% of the motor full load current. NEC Section 110.14c requires that overcurrent devices shall be rated to protect the conductors under fault conditions. The manufacturer's installation manual is a critical resource and should be followed closely. In this specific case, the manufacturer stipulates a 40 amp circuit breaker and number 10 wire. It is important to understand that the provided information indicates the air conditioner pulls 25 amps full load amps, or FLA. As per NEC Section 440.32b, the minimum conductor size should be calculated as 25 amps FLA multiplied by 125%, which equals 31.25 amps. Considering that number 10 wire has an ampacity of 30 amps, as per NEC Table 310.16, it appears to be slightly undersized according to general NEC requirements. Code compliance requires careful consideration of these factors. Technically, the use of number 10 wire with a 40 amp circuit breaker could be seen as a violation of NEC Section 110.14c and 440.32b, since the wire ampacity is less than the breaker rating and the calculated minimum ampacity. However, the manufacturer's instructions explicitly allow for this combination. When addressing these issues, several options are available. Firstly, if code compliance is a primary concern, using number 8 wire instead of number 10 wire would provide a solution. Number 8 wire typically has an ampacity of 40 amps, which meets the NEC requirements for the calculated load of 31.25 amps and aligns with the 40 amps circuit breaker. Secondly, adhering strictly to the manufacturer's instructions and using number 10 wire is another approach. In this case, it's critical to ensure that the circuit breaker is indeed rated at 40 amps as specified by the manufacturer. The decision hinges on balancing code interpretation with manufacturer specifications. Thirdly, consulting with a qualified electrician is always a prudent step, especially when uncertainties arise. A qualified electrician can assess the specific installation conditions and provide guidance that aligns with both code requirements and accepted industry practices. It's important to note some additional considerations. Firstly, the use of a 40 amps fuse is generally not recommended for motor circuits. NEC Section 440.22 typically discourages the use of fuses for motor circuits, favoring circuit breakers instead. Secondly, using copper conductors for air conditioner circuits is crucial for safety and performance. Copper provides excellent conductivity and is a reliable choice for these applications. Thirdly, proper grounding is essential for electrical safety. Ensure that the air conditioning unit and associated electrical components are properly grounded to minimize the risk of electrical shock. Let's summarize the key takeaways. Firstly, calculate the minimum conductor ampacity based on 125% of the air conditioner's full load amps FLA. Secondly, select a conductor size that meets or exceeds this calculated ampacity, referencing NEC Table 310.16 for ampacity ratings. Thirdly, ensure that the circuit breaker rating aligns with both the conductor ampacity and the manufacturer specifications. Fourthly, prioritize copper conductors and proper grounding for safety and reliability. Fifthly, when in doubt, seek guidance from a qualified electrician to ensure compliance and safety. By adhering to these guidelines and consulting with experts when needed, you can ensure the safe and compliant wiring of split-system air conditioners. When sizing conductors for air conditioning equipment, it's essential to consider the specific requirements outlined in the National Electrical Code, or NEC, and the manufacturer's instructions. The NEC provides general guidelines for conductor ampacity, while the manufacturer's instructions often offer specific recommendations tailored to the equipment's design and performance characteristics. NEC Section 440.22 mandates that conductors for air conditioners be sized in accordance with NEC Article 440, which covers air conditioning and refrigeration equipment. This section emphasizes the importance of selecting conductors with sufficient ampacity to carry the intended load safely and reliably. NEC Section 440.32b further specifies that conductors for circuits supplying motors, including those found in air conditioners, must have an ampacity not less than 125% of the motor's full load current, or FLA. This 125% factor accounts for the motor's potential to draw higher current during starting and running conditions, ensuring that the conductors can handle the load without overheating or experiencing voltage drop. NEC Section 110.14c addresses the protection of conductors against overcurrent conditions, such as short circuits and ground faults. This section requires that overcurrent devices, such as circuit breakers or fuses, be rated to protect the conductors under fault conditions, preventing damage to the wiring and minimizing the risk of electrical hazards. In addition to the NEC requirements, the manufacturer's installation manual is a crucial resource that should be consulted and followed closely. The manual typically provides specific instructions and recommendations for wiring the air conditioning equipment, including the appropriate conductor size, circuit breaker rating, and grounding requirements. In situations where the manufacturer's instructions deviate from the general NEC guidelines, it's essential to carefully evaluate the rationale behind the manufacturer's recommendations and ensure that they align with accepted industry practices and safety standards. For instance, in the scenario presented, the manufacturer specifies a 40 amp circuit breaker and number 10 wire for an air conditioner that pulls 25 amps FLA. While the number 10 wire may appear to be slightly undersized based on the NEC 125% rule, the manufacturer's recommendation may be based on specific design considerations or testing data that demonstrate the wire's ability to safely handle the load under normal operation conditions. To assess the compliance of the wiring configuration with the NEC, it's necessary to perform a detailed analysis of the conductor ampacity, circuit breaker rating, and load characteristics. The air conditioner's full load amps, or FLA, is a critical parameter that determines the minimum conductor ampacity required by the NEC. In this case, the air conditioner pulls 25 amps FLA, which means that the conductors must have an ampacity of at least 31.25 amps, calculated as 25 amps multiplied by 125%. According to NEC Table 310.16, number 10 wire typically has an ampacity of 30 amps, which is slightly below the calculated minimum ampacity of 31.25 amps. However, it's important to note that the ampacity of a conductor can vary depending on factors such as the insulation type, ambient temperature, and installation method. Therefore, it's essential to consult the relevant NEC tables and apply any applicable correction factors to determine the actual ampacity of the number 10 wire in the specific installation environment. If the number 10 wire's ampacity is indeed below the calculated minimum, it could be considered a technical violation of NEC Section 440.32b, which requires conductors to have an ampacity not less than 125% of the motor's FLA. Additionally, the use of number 10 wire with a 40 amp circuit breaker could also raise concerns about compliance with NEC Section 110.14c, which requires overcurrent devices to protect conductors under fault conditions. In this case, the 40 amp circuit breaker may be too large for the number 10 wire, potentially allowing excessive current to flow through the wire during a fault, leading to overheating or damage. To address these concerns and ensure code compliance, several options can be considered. Firstly, using number 8 wire instead of number 10 wire would provide a solution that meets both the NEC 125% rule and the overcurrent protection requirements. Number 8 wire typically has an ampacity of 40 amps or higher, which is sufficient to handle the calculated load of 31.25 amps and is compatible with the 40 amp circuit breaker. Secondly, if the manufacturer's instructions explicitly allow for the use of number 10 wire with a 40 amp circuit breaker, it's possible to follow their recommendation, provided that the installation meets all other applicable NEC requirements and safety standards. In this case, it's crucial to ensure that the circuit breaker is indeed rated at 40 amps and that the wiring is installed in accordance with the manufacturer's specifications and best practices. Thirdly, consulting with a qualified electrician is always a prudent step, especially when uncertainties arise regarding code compliance or safety. A qualified electrician can assess the specific installation conditions, perform necessary calculations, and provide guidance that aligns with both the NEC requirements and accepted industry practices. It's important to note that the use of a 40 amps fuse is generally not recommended for motor circuits, as NEC section 440.22 typically discourages the use of fuses for motor circuits, favoring circuit breakers instead. Circuit breakers offer better protection against overloads and short circuits and are generally more reliable in motor applications. Additionally, using copper conductors for air conditioner circuits is crucial for safety and performance. Copper provides excellent conductivity and is a reliable choice for these applications. Furthermore, proper grounding is essential for electrical safety. Ensure that the air conditioning unit and associated electrical components are properly grounded to minimize the risk of electrical shock. In summary, when wiring a split-system air conditioner, it's essential to carefully consider the NEC requirements, the manufacturer's instructions, and the specific installation conditions. By calculating the minimum conductor ampacity based on 125% of the air conditioner's full load amps, selecting a conductor size that meets or exceeds this calculated ampacity, ensuring that the circuit breaker rating aligns with both the conductor ampacity and the manufacturer's specifications, prioritizing copper conductors and proper grounding, and seeking guidance from a qualified electrician when needed, you can ensure the safe and compliant wiring of the equipment. The National Electrical Code (NEC) provides a comprehensive set of guidelines for electrical installations, including those for air conditioning equipment. Adhering to these guidelines is crucial for ensuring safety and compliance with regulations. NEC Section 440 covers specific requirements for air conditioning and refrigeration equipment, including conductor sizing, overcurrent protection, and disconnecting means. Within Article 440, various subsections address specific aspects of air conditioning wiring. Firstly, NEC Section 440.4 emphasizes the importance of following the manufacturer's instructions. The NEC generally requires that equipment be installed and used in accordance with the instructions included with the listing or labeling. Secondly, NEC Section 440.6 addresses the ampacity rating of conductors. It requires that conductors supplying air conditioning equipment have an ampacity sufficient to carry the load, taking into account the full load current flow and any other loads connected to the circuit. Thirdly, NEC Section 440.12 covers motor compressor equipment. It provides requirements for the disconnecting means, branch circuit protection, and feeder protection for motor compressor units. Fourthly, NEC Section 440.22 addresses the overcurrent protection of air conditioning equipment. It specifies the maximum size of overcurrent devices, such as circuit breakers or fuses, used to protect the equipment and conductors. Fifthly, NEC Section 440.32 addresses the conductor ampacity and overcurrent protection for air conditioning equipment. It provides guidance on selecting the appropriate conductor size and overcurrent device rating based on the equipment's full load current and other factors. In addition to the specific requirements in Article 440, other NEC sections may also apply to air conditioning installations. Firstly, NEC Section 110.3b requires that equipment be installed and used in accordance with its listing and labeling. This means that the air conditioning equipment must be installed according to the manufacturer's instructions and any applicable listing requirements. Secondly, NEC Section 110.14c addresses the temperature limitations of conductors. It requires that conductors be selected and installed in a manner that ensures their temperature rating is not exceeded under normal operating conditions. Thirdly, NEC Section 250 covers grounding and bonding requirements. It specifies the requirements for grounding the air conditioning equipment and bonding the metallic parts to ensure electrical safety. When wiring an air conditioning unit, it's essential to consider both the NEC requirements and the manufacturer's instructions. The manufacturer's instructions often provide specific details about the wiring configuration, conductor size, and overcurrent protection requirements. In some cases, the manufacturer's instructions may deviate from the general NEC requirements. In these situations, it's important to carefully evaluate the rationale behind the manufacturer's recommendations and ensure that they align with accepted industry practices and safety standards. For example, the manufacturer may specify a particular conductor size or overcurrent device rating based on the equipment's specific design and operating characteristics. In the absence of specific manufacturer's instructions, it's generally recommended to follow the NEC requirements. Firstly, calculate the minimum conductor ampacity based on 125% of the air conditioner's full load current flow. This is to account for the motor's potential to draw higher current during starting and running conditions. Secondly, select a conductor size that meets or exceeds this calculated ampacity, taking into account the conductor's temperature rating and any applicable dirting factors. Thirdly, choose an overcurrent device, such as a circuit breaker or fuse, that is sized appropriately to protect the conductors and equipment. The overcurrent device rating should not exceed the conductor's ampacity or the equipment's maximum overcurrent protection rating. Fourthly, ensure that the air conditioning equipment is properly grounded and bonded in accordance with NEC Article 250. This is to minimize the risk of electrical shock and ensure the equipment's safe operation. Fifthly, use only approved and listed electrical components and materials. This is to ensure that the components meet the required safety standards and are suitable for the intended application. When in doubt, it's always best to consult with a qualified electrician. A qualified electrician can assess the specific installation conditions, perform necessary calculations, and provide guidance that aligns with both the NEC requirements and accepted industry practices. The electrician can also help ensure that the air conditioning unit is wired safely and correctly, minimizing the risk of electrical hazards and ensuring the equipment's reliable operation. Remember that local codes and regulations may also apply to air conditioning installations. It's important to check with the local authorities to ensure compliance with all applicable requirements. It is also important to note that the information given only represents general guidance and does not constitute professional electrical advice. Always consult with a qualified electrician for specific recommendations tailored to the equipment in question.